Today I'm gonna talk about the derivative of composite function, chain rule, specifically trig function and general power rule, part 2. Now let's recall what is general power rule. The general power rule can be written as the derivative of fx to the power n equals n times fx to the power n minus 1 times derivative of fx. And also we list the standard power rule. The derivative of x to the power n equals n times x to the power n minus 1. We also list some other formula that can be used to solve the following examples. Okay, and this one is constant multiple rule. The derivative of secant x equals secant x times tangent x. The derivative of cosecant x equals negative cosecant x times cotangent x. The derivative of cotangent x equals negative cosecant x squared. Okay, now let's take a look at the first example. First of all, if we wanted to apply this general power rule, we needed to identify what is fx. Okay, so for the first example, we can tell the fx is what? Fx is secant x. Okay, is secant x, and the n is 3. Right? So we can directly plug in the formula. We have 3n 3 and secant x. We have 3 minus 1, and the derivative of fx gonna be secant x prime. Okay, plug in the fx. Now we have 3 secant x squared, and the derivative of a secant x gonna be secant x times tangent x. Okay, and we can combine these two terms. We have 3 times secant x cube tangent xx. Now let's take a look at the second example. The fx is what? Is 7 cosecant x plus 2x to the power 6. Okay, now we can plug in. Okay, plug in here. We have n is 2, and fx to the power n minus 1 should be 7 cosecant x plus 2x to the power 6 to the power n minus 1, 2 minus 1, and times the derivative of fx, that is 7 cosecant x plus 2x to the power 6 prime. Okay, so we have 7 times cosecant x plus 2x to the power 6. 2 minus 1 is 1. Okay, and here the derivative of sum of two functions gonna be the derivative of each function. We just write down 7 cosecant x plus 2x to 2x to the power 6 prime. Okay, and now we can tell for these two functions that is a constant times a function, right? We're gonna apply the constant multiple rule. We're gonna keep the constant the same and do the derivative only for the function. So we have 7 cosecant x plus 2x to the power 6. And here we're gonna keep the constant the same, and we only do the derivative for the function. And similarly, we keep the constant here, and we do the derivative only for the function. We can simplify it. 7 cosecant x plus 2x to the power 6. And here, the derivative of cosecant x should be negative cosecant x cotangent x. So it should be a negative 7 cosecant x cotangent x. And the derivative of x to the power 6 is going to be a power rule, right? So we have 6 times x to the power 6 minus 1. We have 2 times cosecant x plus 2 times x to the power 6. And here we just copy it. And the last one is 12 times x to the power 5. Okay, now let's address the last example. Okay, for the last example, we're gonna follow the same strategy to identify the fx. Fx can be written as 5 cotangent x plus 4 times x to the power 5. Okay, now we can follow this general power rule. We plug in the n equals 4 and fx 5 times cotangent x plus 4 x to the power 5 and the n minus 1 times the derivative for the fx, that is 5 cotangent x plus 4 times x to the power 5. And again, for these two terms, right? For these two terms, we do the derivative of the sum of the two functions. We're going to do the derivative for each function. So we have 5 cotangent x plus x to the power 5 to the power 3. We have the derivative of each function, right? And now we can simplify it. For these two, we can apply the constant multiple rule. Okay, constant multiple rule. Here the constant is 5, here the constant is 4. Okay, so we have 4, 5 cotangent x plus 4 times x to the power 5 cube. We have 5 cotangent x prime plus 4 x to the power 5, and we have phi cotangent x plus 4x to the power phi cube, and the derivative of cotangent x gonna be negative cosecant x squared. So we're gonna have negative phi cosecant x squared. Okay, cosecant x squared. And the last term we're gonna apply the power rule, right? So we have phi times x to the power phi minus 1. We can copy the terms and simplify it. 4x to the power phi cube and times negative phi cosecant x squared. And plus 4 times phi equals 20 x to the power 4. Okay.